look at 10. Okay, very good. And then we have cosine inverse 0. We have sine inverse 0. And we have sine inverse of negative 1/2. For the first one, for cosine, remember where I'm expecting answers. I'm expecting answers here. Cosine 0 is 1. The measure of the x, the unit on the x-axis here is 1. And here is negative 1. Cosine is measured on the x-axis. At 0 degrees or radians, cosine is 1. Exactly. At pi over 2, the x-coordinate is 0. Cosine is always the x-coordinate. Okay, now for sine. For sine, I'm looking at this, including the points. So now I need to determine the angle whose sine is 0 between negative pi over 2 and pi over 2. At pi over 2, the y-axis is 1. The y-coordinate is 1, and here the y-coordinate is negative 1. I'm looking for the y-coordinate. Nope. It has to be an angle. You cannot give me a number. You cannot give me a number. You have to give me an angle. Where is sine 0? The pi, 2 pi is not in the domain. You're correct. But I cannot write exactly. It's 0. 2 pi is the same with 0. Right here.
So you're only looking.
Sine is 0 here.
In between, between negative pi over. So you're only looking for negative pi over 2, pi over 2. The 1 and 1.
But this is, so if I had here negative pi over 2, if I had here negative 1, I would have written negative pi over 2. If I had here 1, I would have written pi over 2. But I have 0. So I'm asked to find which angle has sine 0. That the angle is 0. Okay, let's write the coordinates. 1, 0, 0, 1. I don't need this one. And 0, negative 1. So this is sine, the y-coordinate. So sine of 0 degrees is 0. So sine inverse is applied to a number. So I'm looking for the angle whose sine is 0. Okay, so now I need to determine sine inverse of negative 1/2. Which quadrant do I have that angle? I will find that angle in. Yes, it has to be here. So then it has to be a negative angle. Can anyone remind us which angle has sine 1/2? That we cannot forget. No, pi over 4 is the square root of 2 over 2, and they are both the same. Pi over 6, that's it. That is it. Use a calculator to find the approximate value. You can do that. Let's choose 1 from that. Let's choose 1 from the next set. 13 through 22. 14. Okay, 14 is, here it is. In the graphing calculator, you go back. So second cosine. And I plug in just what I see, 4 divided by 9. Close the parenthesis. And the answer, because my mode is in radians, the answer would be a degree, a number, an angle, a radian, what?
So it's just be degree, angle, right?
It has to be an angle in. My mode is in radians. My mode in the calculator is in radians. So I will get an angle in radians. So press enter. And this is what I get. 1 radian, 0.11. How much is 1 radian in degrees if I want to change it to degrees? Roughly, 1 radian, roughly 57 degrees. So this is more than 57 degrees. If I go back and change my mode to degrees, and I repeat, I just copy second and entry. So I should get a little bit more than 57 degrees or less. I know it's silly.
A little more.
Yeah, here it is. Because it's 1.11 radians. So it's more than 57 degrees. Okay, last set. Between 23 and 44. Find the exact value of the expression.
Can we do one more of this? So if we put in the decimal, it's going to put out the same result.
Yeah,
Okay.
it's going to give you the degree, whatever it is. I put 4/9, but I could have put in the decimal.
Okay.
Doesn't matter, it's the same thing. So 23 to 44. Let's choose
38.
38. Where are you, 38? Very good. So in 38 on page 412, we have sine inverse of sine 11 pi over 4.
Just cancel out.
Say it again.
Shouldn't I just cancel out?
Very good.
Shouldn't it be 11 power?
Excellent.
Wait,
No, of course not. Now, can anyone tell us why it's not the case? Because the answer for sine inverse, right? Sine inverse of a number has to be an angle, that's okay. However, look at where the sine has to be, between negative pi over 2 and pi over 2. Is this an angle between negative pi over 2 and pi over 2? No. So therefore, I'll say no. I cannot use the property of inverse functions, but I can determine slowly what this is. So I have to determine this. Okay. I have to find what? I'm going to determine sine of 11 pi over 4. What is the first thing that I have to determine? Exactly. Excellent. Thank you. The reference angle. Perfect. So first of all, in other words, I have to see where this ends. It's 11 of 45. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 of 45 is this angle. In each quadrant, I have two 45s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You can multiply 11 by 45. Same thing. Good. So that's my angle. So now how much is sine of, what is the reference angle? One more time. In this case, this is the reference angle right here. How much? Of course. So then how much is sine pi over 4? And how much is the, what is the sine of sine in the second quadrant?
The sine of sine.
The sine of sine. Yes, the square root of 2 over 2, but what is the sine of sine in the second quadrant? When the sign in front, positive or negative?
Oh,
Yes, it is positive. Sine is positive at the top and negative at the bottom. Good.
makes sine.
So this is sine inverse of the square root of 2 over 2. Perfect. Excellent. So now I'm asked to find what angle has sine the square root of 2 over 2, but the answer has to be here. Mandatory. Between these two. So what will I write as the answer? And of course not 11 pi over 4, but exactly. So this is a perfect example in which I was not able to use the property of inverse functions because of the way we defined these functions. Because of this. Because of this. So I had sine. The answer had to be between negative pi over 2 and pi over 2. Or here, sine inverse applied to a number had to give us an answer between negative pi over 2 and pi over 2. I could not write 11 pi over 4 because 11 pi over 4 is not here. Good, let's choose one more and then we go to chapter 6. Choose anything else you want.
44.
Okay, 44. 44, where are you, 44? Okay, sine of tangent inverse of negative the square root of 3. Can I use the property of inverse functions? Of course not, because sine and tangent inverse are not inverses of each other. Excellent. Perfect. So then I have to take it slowly. And again, I don't remember what angle has tangent the square root of 3. But I know there are only two possibilities. Right. 1/2 over the square root of 3 over 2. Or the other one, the square root of 3 over 2 over 1/2. Pi over 3 indeed. How exactly. Very good. So now you can, with time, you can remember those, the square root of 3 over 3 or the square root of 3, right? Because you know there are only two options, right? 1/2 over the square root of 3 over 2 creates a big problem. It's the square root of 3 over 3. The other one, for pi over 3, is the square root of 3 over 2 over 1/2, and the 1/2 goes away. That's why it is pi over 3. Perfect. So then finally, I have to determine sine of negative pi over 3. I want to get rid of that negative, and I have to think in terms of odd or even. If it's even, the negative will go away immediately. If it's odd, the negative will go in front. I'm not moving it in front, but because the function is odd, it's the same. Sine of negative x equals negative sine x or equals sine x. Is the function odd or even? Correct. So what will be the answer for now? Exactly. And now I can think in terms of sine pi over 3. I don't have to go around the circle in the negative direction because I'm using the property of odd or even, right, of symmetry. So how much is sine pi over 3? And it's not 1/2. Sine starts with 1/2 at the top. So if the angle is at the bottom, it cannot be 1/2. Exactly. So it's negative the square root of 3 over 2. Of course, you have a way of roughly determining this with a graphing calculator. You can put sine, you can put tangent inverse, you can put negative the square root of 3 in parentheses, and then you will get a number. It will not be a fraction. But you can check. You put negative the square root of 3 over 2 in your calculator and check the answer. Is that clear?
Is there a way to convert it to?
No, if it's an irrational number, you can't. No, you cannot. Okay, so back to where we are. So now we completed this and this and this, and now I'm going back to 6.4, 6.5, and 6.6. 6.4. Okay. It's all about trig function, inverse trig functions again. So problems 1 through 31. Find the exact value of each expression. This is what we just did. So let me just show you the overlap between those two sections. So find the exact value of each expression. This is exactly what we did a minute ago. This is use a calculator to find an approximate value. This is exactly what we talked about, right? Tangent inverse, you plug in a number. Okay. So find the angle theta in degrees rounded to 1 decimal. I would like to determine or solve one of these problems. Please choose. You have 1 through 31, 39, 41, 42. 39, 41. Ready?
15 through 20 or what
1 to 31. 1 to 31.
Who do you like?
So I'm looking at 15 to 20. Just one from there.
18.
Okay, 18. So in 18 we have a right triangle, and with a leg of 30, the hypotenuse of 70, and we're asked to find theta in degrees rounded to 1 decimal. So which trig function we have to apply? Good. So that will be sine. Sine theta equals 30 divided by 70, or 3/7. Now, in order to find theta, what do you think we need to apply to both sides? Something that removes sine.
Inverse of something?
Of course. Absolutely. Have to apply sine inverse to both sides. And yes, sine on the left-hand side goes away, so all I have left is theta equals sine inverse of 3/7. They want us to put in the graphing calculator because there is no way I can determine this. So sine inverse of 3 divided by 7. I already have the mode in degrees, so I press enter and I get 25.4 degrees. So theta approximately 5.4 degrees. Okay, I would like to work on a problem from 21 through 26. Please choose. Do I still need the tent here? I think I don't anymore. Okay, so 21 through 26, please. This is a very important type of problem. We're going to deal with it a lot in chapter 7. 23. So sine theta equals 0.7. And the problem is asking us to find all angles theta between 0 and 180. Between 0 degrees and 180 degrees. Okay. So please follow me for a second. Please tell me how much is sine here. 0. How much is sine here?
0.
Good. How much is sine here?
1.
Okay. Where do you think this angle is, roughly? So closer to this, right? Because a height of so this is a height of 1. A height of 0.7 will be roughly here, right? If you say, well, this is 1, this should be 0.7. Would you agree? Okay. At 0.7, I'm going to draw a horizontal line. Where it meets the circle, I will have one angle, and I will also have a second angle will have the same sine. How much? How much will the sine be? 0.7. This height is 0.7, and this height is 0.7. So there are two angles. One with the terminal side in the first quadrant, and one with the terminal side in the second quadrant. So let's determine them now with the use of the calculator. So how do I determine the first one? I apply sine inverse to what? To 0.7, of course. So I get 44.4, let's say. Okay, so one angle here, this one, alpha, I'm going to call it alpha 1 or theta 1, whatever you want, 44.4 degrees. Now, I don't need a calculator, and I can determine it with a calculator. I could, just one part. So how do I determine the other one? We are between 0 and 180. But you're right, you're thinking in terms of where the sine is defined for the inverse function. I agree. But now we want that other angle in the second quadrant. If you're thinking about negative, then the sine will be negative 0.7.
Okay. So
how do I determine
the reference angle from that side?
Of course. What has to be the reference angle? How much?
0.3.
The reference angle. Doesn't it have to be the same? 44?
Oh, so it's 44 minus 180?
180 minus 44.
Oh, yeah, that's what I meant, yeah.
Exactly. It has to be the same, right? Otherwise, the sine would not be 0.7. So 180 minus the previous answer, not the previous entry, sorry,
So 135.
minus the previous answer, and I got 135.6. So my alpha 2 is 135.6 degrees. So the reference angle is the same with the first alpha. So this is alpha 1. This has to be alpha 1. And this second one is alpha 2.
Okay, yeah. I thought we were trying to find that little sliver alpha.
No, the reference angle. Remember, the reference angle is always with the x-axis.
I thought we were trying to find the other reference angle.
Okay. Is that clear?
Yes.
Okay, do we need another example or not?
Yes.
Yeah, can we do one more?
Yes. Which one?
26?
26 cosine theta equals 1/9. And this is 26. Good. And we're asked again, find all angles, theta, between 0 and 180 degrees. So now, how much is cosine here? How much is cosine here? Good. So 1/9 is tiny, right? It's 0.1. So how close? Where will I be? Closer to this or closer to this? Yes, exactly. So this is roughly, I'm going to say that this piece from here till here, yes, 1 second. So between, you're right. So between these two is my 1.1 divided by 9. So here's what I draw now. Okay. So I have an angle that ends right here and an angle that ends right here. This angle is this. The other angle, although we shouldn't talk about it because we are asked between 0 and 180, I want to talk about it. So in this particular case, we should not consider the second angle because I'm specifically told between 0 and 180. And this angle is not between 0 and 180. It will be more than 180. But I want to talk about it because I need it later. So this is our alpha 1 and this is our alpha 2. Although alpha 2 is not in the domain and I will not have to consider it as an answer to this problem. Okay, perfect. So then how do I find alpha 1?
Cosine inverse?
Of? Exactly. So let's put in cosine inverse. Second cosine inverse of 1 divided by 9. And I get 83.6 as I expected, as you said perfectly, 83.6. So alpha 1 equals 83.6 degrees, and there is no other answer. But for what follows in chapter 7, I would like you to find for me alpha 2. What is the reference angle for alpha 2?
360.25.
What is the reference angle for alpha 2? It must be the same angle, otherwise they will not have the same cosine. It must be 83.6. So this piece here must be 83.6 degrees, no question.
Would be negative.
Reference angle is always positive.
Yeah.
Reference angle is always positive. So what is alpha 2 then? From 360, you subtract 83.6. That's why I asked about the reference angle. So 360
So 276.
minus the previous answer, 276.4. So not an answer here, because we're specifically asked to determine between 0 and 180. Okay, final question, please choose 27 through 32. Which one?
31.
Which one?
31.
Okay. So we're asked to find tangent of sine inverse of 12 over 13. Excellent. Good. Good pick. Okay, so this is tangent. What is this? I don't even want to look. Tangent is applied to,
It's not like this.
don't forget, there is nothing there, just my hand.
Oh, 0.
What is this? This is tangent applied to what? Of course. Absolutely, absolutely. That's all I wanted you to say. So I'm going to call this angle alpha. I can't have here anything else but an angle. Is that clear? I cannot apply tangent to anything but to angles. Any discussion there? Okay, perfect. So I'm going to call this angle alpha. You can call it beta. You can call it theta. Whatever whatever letter you want to use. So now, what do you think I'm going to do to both sides? Of course, I will apply sine to this side, and I'm going to apply sine to this side. So then I have that sine alpha equals, excellent. Let's go back to a right triangle with an acute angle alpha. And tell me what is 12, what is 13, and where it is.
Oh, so opposite over hypotenuse.
I'm ready. What is the opposite?
12.
What is the hypotenuse? Can I determine this?
Yes.
Okay, so it's the square root of 13 squared minus 12 squared. Whatever that is. So that's 169 minus 144. That's 25. The square root of 25 is 5. Good. Coming back here. What was I asked to determine? So what was I asked to determine?
Tangent of they or that
Good. Give me the tangent, please.
Oh, so
12
opposite.
That's it. No.
opposite over.
It's
Oh,
opposite over
adjacent,
adjacent.
so-
So 5.
That's it. Done.
That was easier than that.
Right. I know we know another one, so please choose one more so we can move on.
29.
29 it is. Where is it? Secant of sine inverse of 12 over 13.
No, actually.
I know it's the same. I didn't really want to do the same, but it's okay.
I mean, to do the same. I was like, oh, we're seeing
Okay. So what is this?
an angle.
Secant alpha, right? Okay. So I'm going to say alpha equals sine inverse of 12 over 13. So I'm back here.
Yeah, so we're going to do that again.
Right. So I'm back here, right? But now I'm asked to find secant. So cosine is 5 over 13. Then secant is,
13 over 5.
that's it.
Solid on my part.
Good. Questions? Okay. Last two sections. 6.4 and 6.5 together. These are two laws. Law of sines first. In any triangle, not right triangle, in any triangle, we can write the following theorem. Here's a triangle. I mentioned this a while back, that if you denote the vertices by A, B, and C, you must denote the sides accordingly. What do I mean by that? The opposite side of angle A must be denoted by lowercase a. The opposite side of angle B must be denoted by side lowercase b, and the opposite of C must be denoted by lowercase c. So law of sine says that sine angle A divided by the opposite side must equal sine angle B divided by, what do you think? And this must equal sine C over C. In any triangle, including the right triangle if you want. So I like to use an example. Yes?
So if you just divide the sine angle divided by just their side, the measurement of the side.
Yes.
they're all
So
the
these,
same.
yes,
Okay.
yes. Okay, on page 473. Solve the triangle using law of sines. Now, before we do that, I just wanted to mention the following. In any case except side-side angle, in any case except side-side angle, the possibilities are these. Here are the options. 1, triangle exists, or 2, triangle does not exist. However, side-side angle is called the ambiguous case. Side-side angle. This is special. It has 3 options. This is the only one with 3 options. For side-side angle, option number 1, triangle exists. Option number 2, triangle does not. Option number 3, 2 triangles exist. It's called the ambiguous case. Ready for an example? Let's say problem 20 on page 473. We are given A equals 30, lowercase. Lowercase c equals 40. And angle A is 37. We're asked to use the law of sines to solve for all possible triangles that satisfy the given conditions. So side little a is 30, side little c is 40, and the angle A is 37. I have to draw a triangle. I have to label the vertices and very carefully find and place the information in the correct spot. So angle A is 37. That's 37 degrees. Lower side, opposite side is 30. A equals 30. B is unknown. I can write B. C is given to be 40. C equals 40. If this is the case side-side angle, I have to identify it. If this is the case side-side angle, I have 3 worries. Is it 1 triangle? If you want to say, is it does not exist, or is it 2 triangles? Possible. It is side-side angle. Side, side, angle. In order, side-side angle. So since it is side-side angle, I have to be very careful. So give me the proportions. First of all, let's write the theorem one more time. Sine 37 over 30 equals sine B, which I don't have, over B, and equals sine C that I don't have, over 40. Which of these proportions will help me find something? The first one with the last one. This one cannot be involved yet because I don't have anything there. There are 2 unknowns, top and bottom. So 40 sine 37 equals 30 sine C. What can I determine from here? What can I find from this?
What the angle is.
Exactly. I have to find first sine C.
So you divide by 30.
And then what do I have to do to find C? Yes, apply.
C cross multiply.
Of course, it's a proportion, yes. Sine C equals 40 sine 37 divided by 30. So then sine C with the graphing calculator, what do I get? So 40 times sine 37. Make sure you're in degrees, because otherwise you will get something very weird. I got 0.8. Would you agree with 0.8? How do I determine C? What do I have to do to both sides to determine C?
Find the inverse.
Apply the inverse. So sine inverse of 0.8. So apply sine inverse to this result. And I got 53.4. C equals 53.4 degrees. Would you agree with that? Not good enough, though. Let's go back to the unit circle. The height of 0.8, if this is 1, would you say 0.8 is about here? Okay, I have to draw a horizontal line at 0.8. And I see that I get two angles. One that ends in the first quadrant, and one that it ends in the second quadrant. So I'm going to call this C1, and I would like someone to give us C2.
126.6.
Excellent. 126.6 degrees. Okay. Coming back to our triangle. So I'm going to make a list. Triangle 1, triangle 2. I don't know if the second one exists or not. I have to consider it though. So A is the same in both. A does not change. There is no problem there. B1, C1. C1 will be 53.4. B2, C2, 126.6. Can anyone give us B1? So from 180, I subtract 37. I subtract 53.4. I got 89.6. Good. And then from 180, I subtract 37, and I subtract 126.6. I got 16.4. It appears that there are two different triangles possible here. However, we're not done, because we have to determine side B. So A and C are fixed. I can't change those. Little a is 30, little c is 40 in both. No one can change that. But now I have to determine lowercase b. So from this proportion now, I'm going to write it here. Sine 37 over 30 equals sine 89.6 over b. I will determine little b1, so b1 and b2. b2 will be determined from sine 37 degrees over 30 equals sine b2, 16.4 degrees over b2. So b1 is 30 multiplied by sine 89.6 degrees over sine 37 degrees, and then b2 will be 30 multiplied by sine 16.4 degrees over sine 37 degrees. I'll calculate b2 and somebody will calculate b1. So b2, 30 sine 16.4. Close the parenthesis, divided by sine 37. I got 14 roughly for B2. How much did you get for B1?
49.8.
49. 49.8?
Yeah, 49.8.
I'm going to write 49.8 then. So in this situation, so we hit a case in which it was side-side angle, and it happened that it had two possible triangles. And here is the final answer. All sides are angles, all sides are angles.
So is the only way to try out version to do this is if you start subtracting and it becomes more than 180?
No. One possibility is when you get sine B, 1.2. Is there an angle whose sine is 1.2? How is the maximum for sine? Yeah. Or if you get cosine, or you get, that's the next thing that I want to show you, and then we'll stop. Law of cosines. And this is the last thing for test 2. We'll review everything again on Monday. So, law of cosines. Again, in any triangle, including the right triangle. Okay. A, B, and C, and A, B, and C. If I write this, what would you say? The triangle must be right triangle, but I'm going to continue. How much is, if it is a right triangle, how much is cosine of the 90-degree angle? Cosine of the 90 degree, you have to give me a number. Exactly. Exactly, 0. That's why this disappears. So that's why we have the Pythagorean theorem, because this angle is 90 degrees and cosine is 0. B squared equals A squared plus C squared. If I stop here, what will you say? But can you please come up with the last part?
Minus 2A, C.
Excellent.
What's that mean?
Exactly. So if you know one, you know the other. What about C squared equals A squared plus B squared? If I stop here, you'll say, oh, this is the hypotenuse, these are the legs. But this is for any triangles. How will I continue then?
Minus 2AB.
That's it. Let's look at an example, and then I promise to stop. Let's say problem 16 on page 480. A equals 10, B equals 12, C equals 16. Last problem. I know I have 5 minutes left, just this problem. We're asked to do the same thing. We're asked to solve the triangle, in which we have to determine what? What is left that I don't have? The angles, indeed. So let's draw the triangle. A, B, C. The opposite of A is 10. The opposite of B is 12. The opposite of C is 16. Which angle do you want to determine?
A.
If you want to determine A, then which of these 3 possibilities will you use?
The top.
Of course, because that's the only one with cosine A. Excellent. Perfect. So A squared. Don't calculate anything, just write 10 squared equals B squared, 12 squared plus C squared, 16 squared, minus 2 times 12 times 16 times cosine A. Here's what I'm going to do to determine this. Okay? Because I don't want to plug in the calculator anything till the very last step. I'm going to move this term to this side because it's negative and I wanted to make it positive. And I'm going to move this term to this side. So 2 times 12 times 16 times cosine A equals 12 squared plus 16 squared minus 10 squared. And now please tell me how to get cosine. Don't calculate anything, because we're going to put everything in one step in the calculator. Exactly, by this, in front of cosine. Excellent. So 2 times 12 times 16, 12 squared, 16 squared minus 10 squared. Let's put in the calculator. Parentheses around the top. So clear, I'm going to clear everything here. So parentheses around the top, 12 squared plus 16 squared minus 10 squared. Oops, I did it. Okay, close the parenthesis, not there, of course. Here. And divide by parentheses. Don't forget parentheses. 2 times 12 times 16. 2 times 12 times 16 times 12. If the answer is 1.3, what will you say? What if the answer is 1.3? What would you say?
It doesn't exist.
Correct. So, oops, I did something. Okay, I trust you.
Yeah, you put it in that little
Of
box.
course, I know.
That bit.
Okay, so I'll trust you. This is one time I do. No, I'm kidding. Okay, how much is it?
I got 0.7.
Did anyone else get 0.78? Okay, so this is not the ambiguous case. Not possible. When I have three sides, this is not the side-side angle. So in this situation, the triangle exists or it does not. Okay, since I determined that, I can determine cosine. What is A?
So inverse cosine.
Yes,
Inverse cosine.
of this number. What did we get?
38.7.
0.7 degrees. Okay, very good. So I have this, which is 38.7 degrees. Let's just write it. We're not going to solve it, but let's write the same thing for C, and you'll find C. And once you find C, then you subtract from 180 to get this one.
Okay.
So just give me for C. What would you say? Which one of these?
Oh, that bottom.
Right. Let's just write it initially, and then I'll let you finish it. 16 squared equals 10 squared plus 12 squared minus 2 times 10 times 12 times cosine C. And you repeat the process. You determine C, and then B by subtracting their sum from 180.